an onion.
Oh my God. Gotta send it to Vince.
Guys, can you please do the warm-up? Stop chatting. Shh. Okay, so people were discussing pop quizzes. There are no pop quizzes yet, though you do have a test on Thursday, and Friday is your first FRQ that will be a real one that will count for a grade. And recall that one of those through this quarter will be dropped, the lowest one, and if you are absent one Friday, that's the one that's dropped. No, it's not crazy, because first of all, you're supposed to be in class. You're not supposed to be like planning on, well, I have a doctor's appointment every Friday. And it collectively, I need to know how you all did on that one question, and then I'm going to go over it in class that same day. Doing it later, not helpful. Noah?
What if you actually have an excuse?
Okay, if you're actually absent, that's still your one that's dropped.
Whoa.
But
Like,
what?
if you actually,
Like if we have stuff planned
Okay.
far in advance, and then we have like what if I plan something before the semester started?
Guys, don't argue about
What
it.
if we
Like,
have two things planned, right?
First of all, these are all hypotheticals. Your job as under 18 students is to be in class, during class. Over 18, you guys can write your own note and get out of whatever you want. But you're supposed to be here. So that's the idea. And if you're planning on finagling the system, we can go with that. Remember, I get to choose the FRQ that you pick. If you don't pick the one that the class has, I will have to choose a different one. I have already chosen the best one, so that means the one that you would have to take as a makeup would be inferior, aka harder.
Wait, that makes the assumption that the best FRQ is the easiest.
No,
which
the one
sounds
that is
wrong.
the one that is suited to your mental state at the moment, which changes day by day. So choosing one like last week that had to do with L'Hopital's and area under the curve and fundamental theorem of calculus that we were just doing, that was chosen on purpose.
Yeah, I thought that was very convenient.
Yeah, it's not just convenient, it was planned. However, not all of them are so well suited. So, try the warm up. Physics people will do better on this. Still?
Where are you going?
I'm also getting the opportunity to
Oh, I planned this like
Well,
a month and a half ago.
I get
You're gonna go for
I think he'll be there.
So I only those.
Oh, that's nice.
$50 for
Yeah,
what?
nothing.
Maybe I should work really
That's
hard to become an
frustrating.
amazing dancer that gets invited to an
All right.
dance program.
Use more
So-
money than you gave, but you know what?
Guys,
And time is money.
so I see blank papers. People are unable to start. So,
Oh, that is so unfortunate.
okay. When we did derivatives, okay, projectile motion last year in pre-cal, we had things like the height of some projectile was,
Equation for your position.
Oh, I remember this.
and then derivative of position
Okay, wait. I got this. This kinda
is
easy.
velocity. And then double derivative position is change in velocity. When you're in a car and your change in velocity, you are going faster and faster. What is that called? Acceleration. So last year, projectile motion, like we told you, oh, gravity's this, initial position, whatever. So working backwards now. Here I'm giving you acceleration. You integrate acceleration to get velocity. You integrate velocity to then get position. All right, so this question, find an equation for your position at any time t. How do I start?
Well, we know that, yeah, we just said that the position is going to be, or the velocity is going to be the derivative of position. So the position is equal to the integral of velocity.
Right, and I don't have velocity. I have a specific coordinate of velocity.
Oh, I wrote, I made like v of t a function.
Okay. Okay, what is the function for v of t?
Oh, I see. The integral of acceleration, which is,
And acceleration, gravity, just a constant.
Right.
So the integral, Eric, what is the integral of negative 32 dt?
The integral of negative 32 dt is negative 32 t plus c.
And I'm going to put a little 1 on it because I'm going to have to integrate again and I'm going to get a different constant. Okay, Morgan, any idea how I can find out what that c is?
Wait.
Thanks, Carson. I told you the velocity at time 1 is 20. So now that we have this general equation, what is c? Positive 52 is what I get. Yes? No?
Positive 52.
Mm-hmm. So my equation for any old velocity of this object, negative 32t plus 52.
Then you just do the integral of that.
Okay, so doing the integral of the velocity gives me position. Okay, so what is the integral of this velocity?
I remember negative 16 x squared.
Oh, yeah. Yeah, that. It was just
Raise the power, divide by the new power. So we're undoing power rule just because you guys remember this from pre-cal, which is great. But negative 16
t squared plus 52 t
plus some other constant. And like,
Then we can so then we do the same thing for.
so at time 1, the position I'm telling you is 50. So t is 1, negative 16 times 1 squared plus 52 times 1 plus that, 18? Yes, no? I don't know. I didn't do this one in advance. Maybe you're not writing anything. So the equation, any old position equation is negative 16t squared plus 52t plus 18.
What's 18? How'd you get 18?
How'd I get 18?
That's all what c is.
Time 1, I'm telling you, where you were in 1 second was 50 whatever feet. So, Eric, put in 50 for position, 1 for the time, negative 16 times 1 squared, plus 52 times 1, plus C2, subtract 52, I get negative 2, add 16, I get positive 18. Yes, no?
I see my fault in my calculation.
You got it? Okay. Isaiah, how do I get the position at time 5? Like, what's the math that I need to do? So position at time 5. $52 times 25 plus 18, whatever that comes out to. 400 plus,
Oh.
I don't know.
140 plus 18. 158.
What do you get, Will?
No, it's plus 14.
Plus 14?
I went in the wrong direction.
Oh.
Amalia, what did I do wrong?
14%. And if you,
It's
you can
-2
combine
plus
negative 62, that gives you 14.
Adding 16 to the other side? Oh,
Yeah.
so negative
You
2,
can
yep,
multiply.
that's negative 2 plus 16. And I'm still doing it wrong.
It's 52 times 5, not 25.
Why don't you just add the 16? Yeah, it's 14.
Whatever that comes out to. Okay,
Negative 1.
Why are you writing this?
negative 126. Sorry, what?
Why are you writing?
Why am I writing S? Because in physics, for some irritating reason, they use S to stand for position.
But it looks like a 5.
Yeah, I know, it looks like a 5. I tried to make it look like an S, but sorry.
I wish it was like a Z where you had that little line that you could put in the middle, so it really doesn't look like anything else. It looks like a Z.
Okay, good talk. Okay,
That is so mean.
all right. So you should have in first semester maybe gotten some relationship of the acceleration to velocity to position. Given acceleration, integrate up. Given position, do the derivative down. Cool. And this little thing, hey, pre-cal, we did those projectiles. Last year we used to launch the most annoying kid and we would make them not hit the safety net. You guys are so mean. I'm like, should we, where do we put the safety net? Ha! 5 feet short. You guys are mean. Yeah, Isaiah.
So, which,
What?
what?
Wait, what? We would launch somebody out of a cannon. Woo!
Oh, yeah.
And the class, I would ask them, where should we put the safety net? And you're like, you would all calculate the person to land not in the net. Mean. And literally, you were calculated about it.
Kevin cried.
Isaiah, I'm sorry, your question? Which one is our equation for a position at any time? It is right here.
They were the corners.
Now that I found my initial velocity and my initial position and found all those C values, this is the equation for position at any time. And then plug the time in that they're asking for. Oh, at 4 seconds, at 1 second, at whatever seconds, you should get it.
What happens if you like take the integral of position?
If you take the interval of position, I don't know what that is.
Can we Google it?
Base time, I don't know.
So, it's somewhere.
Okay. So can you guys try this problem just in the general? I'm giving you the double derivative and some other values. So it doesn't have context of acceleration, velocity, position. Try that. Mael, Morgan. It's not 4 o'clock yet. You can't play that game yet. So say, what are we doing, Isaiah?
So you have a double derivative of f of x, which is 3x. So you have to integrate it twice.
So Isaiah says to get the first derivative, we integrate the second derivative. Okay. So Logan, what is the integral of 3x dx?
3 over 2x squared.
3 over 2x squared. Logan?
Plus c.
Thank you. Plus c. Liv, what do I need to do to solve for c?
You need to set it equal to the next derivative, so you need to set that number equal to -3. And then you need to plug the x value in, which is 1, which leaves you with 3 over 2 plus c equals -3. And then you just do like algebra, which is -4.5 equals c.
So a general equation for f prime of x is 3 over 2 x squared minus 4.5. It's weird to have decimals and fractions together, but you can make that -9 over 2. Are we okay with this? Can? What do I do now, given that I'm asking for an equation for f? I've got f prime.
You have to find the integral.
So f of x is the integral of f prime. Which is what? What is the integral of 3/2 x squared?
It would be 3 halves x to the 3 over 3. So, yeah.
I'm going to raise the power to 3, divide by 3, but I have a 3 in the numerator, canceling with that. So I'm just left with the 2 that was there all along.
Right. And you have -9 over 2x plus c.
And that I already used c in my problem somewhere. I'm going to give a different name. Jackson, what do I do from here?
Then you use the given f of 1 equals 25. And then you set that equal to 1 in the equation.
Don't set it equal to
Or
1.
you like plug it in.
Plug in 1 for x.
Yeah.
Okay.
And then you solve, and it should give you, I think, 29.
I think I got 29 too, but I've been wrong a couple of times today. Sam's agreeing. So Jessica, yeah? Yeah? Rasheen, do you agree?
I agree.
Okay. All right. Well, Thatcher says it's okay, then there we go.
I understand my insight.
So the function x cubed over 2 minus 9 over 2x, and we already solved for that c to be 29. Okay? Niall?
I get the process. I just did something wrong.
Okay. So Friday, I think it was, you guys had a worksheet that was on doing definite integrals, and the answers were on the bottom of them, but I wanted to go over questions from that worksheet. And yeah,
We did the last 3 on each page.
the last 3 on each page from that. Sure.
Well, there's-
So like these things is what I was talking about. That?
Yeah.
Okay.
It was like 6, 7, 8.
Yeah, those are that like they might make more sense now that we've just done those first two problems. So, Lanham, if you guys could find the worksheet, you should still have it. But Lanham, here it tells us g prime is cosine, and it gave me this value and asked for that value. So, sounds like I need g. How do I find g of x?
What was the answer?
Let's see,
29.
I started with doing, what if I'm looking for? So you would say g of x.
I got
43.
I'm trying to give you guys like decipher my work. So I started by doing like.
I think about the one we just did as a class.
So, if I gave you g prime, to find g, I need to integrate.
Yeah.
So what is the integral of cosine? That's the same as saying what function's derivative is cosine? Positive or negative? Positive. And this was an indefinite integral, so I have to have something plus c. All right,
Oh, that's where I messed up.
plus c. Plus c. How do I solve for c? Asher, this Asher.
You said g of pi equals sine pi plus c.
Okay, so g of pi is 7. Unit circle, Sydney, what sine of pi?
0.
0. So c equals 7. So my equation for g of x is sine x plus 7. So Carmen, how do I finish the problem and find g of 3 pi over 2?
You plug in 3 pi.
What is sine of 3 pi over 2?
It's -1.
So overall, -1 plus 7 is 6. Making a little more sense?
Yeah,
If you forget the plus c, it's a problem.
it does make sense now that we all actually.
Okay. Um.
Wait.
Yep. So you need to be familiar with all this interesting, unusual ways they can ask these questions. G prime is this. A specific value of g is here. Okay. I need to find g of x, so I need to integrate. Don't forget plus c. Here they're saying, let h be an antiderivative of, what does that mean?
The integral.
H is the integral of this. So Francis, integrating x squared minus 2x, what do I get? Iris, what are we missing? Plus c. One, what do I do to find c?
Not sure. Oh, you plug in. Or you said equals.
Okay, what goes over here? What is, do I put in -3?
-3.
Is the -3 or is that the 4? The whole problem thing says h of -3. So when I plug in -3 for x, the function is 4. What is -3 cubed over 3? What's that going to end up being? Is it 3?
9.
9?
Negative.
-9? Which one?
Negative.
-9. Because negative times negative times negative divided by a positive ended up being negative. -3 squared is +9, but I was subtracting it. So what does the c end up being, Will? Yes, 22. Going back to the equation for h of x, x cubed over 3 minus x squared plus 22, then Jordan? How do I find h of 1?
You plug in 1.
So 21 1/3. So 64 thirds, something like that. Okay, so Asher, do we need to do more of these or
I think they're the same amount.
they're similar? Noah, what's
The question about the delta.
okay?
There was like a section about hypostic and exponential function section.
Oh yeah, I
Okay.
was struggling with that one too.
Exponential functions.
It's like, how do you integrate pi to 1/2 x?
Oh.
Or is that what you asked?
We're talking about the one that's like 16.0.2.
Yeah.
Yeah. Also,
Just have to know how to integrate
the integral position just does not exist.
It doesn't make sense. Like in the physical notation of things, it doesn't make sense.
I remember that question.
Also, I have a question,
Okay.
which is, there was a question which I got wrong.
So, do you remember the name of it? Like,
Yeah, scroll down. Derivatives of integrals.
so, all right.
Wait, this one was easy.
Isn't that one a constant?
That one's kind of. Is that the one?
This is easy.
That one's weird because it has it's like E is considered a constant. I pressed C solution on that one.
Okay. Well, let's think about it.
In this thing, what's the variable? Is t a variable? Yes. Is e a variable? No, it's a number.
I appreciate it.
So if I was going to integrate x to the third, raise the power by 1, divide by the new power, add c. All right, so here, t to the, that plus 1, it's kind of gross, divide by the new power. That's totally gross. How do I integrate this thing? Can I raise the power, divide by the new power on this one, or is e a different kind of function? Is 1 over e just a number? Is this the variable? So it's that is like 1/3, and then I put a letter next to it. Okay, hang on. Okay, Eric, if I was just integrating 3,
Is that the whole?
no, plus c. I know they were mean and they use e. They like to use e and pi because they look like variables, but they are numbers.
So if you had like
Okay,
pi, the integral of pi is pi x.
the integral of pi, which is 3.14159. You guys went on with more decimals than me. It's just a number. Pi x plus c.
Yeah.
Okay. Things that I don't even see on the BC exams. If you see ones, like I can't control what they're going to raise to a power. E to the x you need to deal with. But anytime if I let the questions ask you e to the x things, they might throw in this.
Yeah, that's what I was.
Yeah,
Okay,
I have to
so
figure
you
this
can
out.
skip those, but okay. What is the integral of e to the x? E to the x plus c. All right, the integral of 3 to the x is 3 to the x, but it's a poser. It's not really e. It's just some cheap knockoff like Canadian quarters. Sorry for any Canadians in here. So there's this adjustment translation fee. Just divide by the natural log of that base.
And then
But
you
again,
need to
you don't-
divide by the derivative of the exponent.
Okay,
Because I spent a lot of time on this morning in Pascal. This was me.
Integral of e to the 2x.
It's over 2.
Integral of e to the stuff is e to the stuff divided by the derivative of the stuff. Yep.
Can we write stuff on the exam?
Don't. My other classes are using the word derivatize. It's not a word, people.
Does it just take
Like-
the derivative?
Is
Like
it not
it's not
the
like cool math lingo. Like no, you're just sounding stupid. But
Where is my
integration derive?
derivatize is not a word. I say
Derive.
it anyway.
No.
Do we need to do this one?
We should be honest with
Okay, try it. I would also like to go over more of yesterday's, the fourth question on yesterday's free response stuff. The third one is just hard. I'd rather not do that one and use it.
F of 0? Yeah.
So you, those of you having trouble reading this, it is on a worksheet that should be in your possession. It was. So it was given as homework and the answers were on the bottom. But just in case y'all had questions about it, and I'll make sure you got it right, we're going over it now.
I was struggling with some of the things, but then I used that AI, that chat. It got it wrong, but it only got it wrong at the very end because it messed up with one thing. So then I put in like a little report, like everything was right up until this.
And you know it was wrong at some point.
Well, I knew it was wrong at the very end because it got like a Sokotoa thing wrong. It was weird.
Goofy.
It's the interval.
It's not that below that, so it's not below.
Integral of sine x negative cosine.
Yeah.
What would change if you were to do dx over dy? Would it just make all the?
It's just weird, but we do it. You guys won't need to, but we do it in BC. Like runners, how many of you in here are in track? No one runs. You ran.
It's a
Like, okay. So, no. Someone asked about it. Okay, technically this is in your curriculum and I have
Wait,
never
didn't we
seen
learn
it.
this?
Yes, I did show it to you in a hot second. I never see this on the BC exams. I'm kind of thinking they're not going to come at you with it. But somebody asked, so just the pattern of if it's y equals some number to the x, the derivative is, it's just like e to the x, it's that to the x times natural log of whatever that number was. You don't need to remember it. Odds are against it being on there. I play the statistics all the time. Despite hating statistics, I do it all the time. There was something else. Oh, Liv, you asked about would we ever do dx dy. Usually you speak in miles per hour, but if you ask a runner, what's your time for the mile? That's miles.
Hours
That's
per mile.
hours per mile. They will know. And I've definitely
This is
been
like splits.
I've been schooled by kids. They're like, I heard about a 412 right now. Okay. We're gonna crack in 8 minutes myself. Yeah.
You got it.
He's a marathon runner.
Okay, like we can stop.
For this problem in particular. Okay.
This is something like
You should consider yourself a runner.
Keith, how do I start this problem? I have this differentiable function. When x is 0, the value of function is 2. The first derivative is sine x. What do I do? Okay, integrate sine x. Okay, whose derivative is positive sine? Keith says negative cosine, and maybe there was some constant hanging off of it.
Maybe.
Okay. Natalie, how do I figure out what that plus c is?
Because it gave you f of 0 equals 2, so you're going to plug 2 in. Well, not plug in, you're going to write 2 where it says f of x, and then plug 0 in 4x, and that will let you solve for stuff. It will be 3.
And cosine of 0 is 0? 1. So this is a thing, like, be careful. The things that you will plug in 0 and be like, oh, whenever you plug in 0, you get 0. No, cosine of 0 is 1. E to the 0 is
1.
5 to the 0 is
1.
There we go. So f of x equals negative cosine x plus 3. And then they asked us in the end, what is f of pi? What is cosine of pi? Negative 1. So negative 1 is positive 1. So this comes out to be 4. Yay! Sam's like, sure, whatever.
No, I did.
I
had it.
agree. I got it.
I was like, maybe Miss Pascal will tell me. It was really like the best moment in my math
Oh,
career.
okay. So what is f of pi?
4.
Good
job.
But I had it done minutes ago. So
Minutes ago.
Why
All
have
right,
this done years
so
ago?
You guys are feeling good with this. All right. The kinds of things on the test. You still need to remember L'Hopital's rule, and you've got to do the damn notation correctly, people. Yep. No. Have we met? Yeah, no calculator. Though I do, on the next half day we have, I want to show you guys how to use the calculator to do things for the calculator test. Because, it is the hardest portion of the test because you guys don't know how to use it. You type things wrong.
Maybe you should let us use the calculator.
No, because I find when I let you use your calculator, you get stupid. Like, what's 5 plus 2 divided by 1? You're like, I don't know, let me type it in. No.
8.
I still struggle with that.
43.7 e to the pi. I don't know. You can. Okay. There are things that distress me.
you should go find out what that is right now.
E to the pi.
Yes, go find that out right now.
Isn't
Is this all of
Isn't- E to the pi I?
Okay, chapter 5. Chapter 5 is all kinds of things.
Or is like we're going all the way back to like the sums? Like is that gonna be all
It could, okay? Like anything, the
It's gonna
AP
be a little
exam, the AP
mysterious
class,
right now.
anything we've done in the past might come up again, especially on those free response questions. Often, there are things that do the right rectangle approximation method with the table of values we have here. That is finding the integration using rectangles. Then when is this doing something? They'll ask things about it. And then they're often a calculator question where you'll need to check the integration actually on the calculator. Was this an over approximation, under approximation, and all that fun stuff. Okay, what's on the test? Fundamental theorem of calculus. And that is 2 different things. That's being able to integrate from A to B, and so I'm using their notation. Little f will integrate to be capital F. So as someone just did, the integral of positive sine was negative cosine, Keith told us. So, and then plug in the top minus plug in the bottom and get a number. That's one of the fundamental theorems of calculus. The other one is just to be mean about it, sine x, yeah. What's the derivative of the integral?
Oh,
F of, this would be f of, plug in the top,
Sine minus
times the derivative of sine x, minus.
f of x squared times 2.
And normally we would have written this stuff up front, but I didn't leave enough space for it. But, so fundamental theorem of calculus, be able to integrate on a definite bounds, plug in the numbers correctly. This is,
it should be f of x or f of t. Will we get like points taken off if we like switch them around?
Not really.
Is that the one with like the 0 and an X with the?
Yes. So the derivative of the integral. So I made both of these moving bounds. So it was the hard one. Plug in like the derivative of the integral. These guys kind of cancel out. But you gotta do a little cheating business. F of sine x times derivative of sine.
Is this all that's on the quiz?
Not the derivative of this function. No, there's more than this.
What else?
So-
Let's get to the other subjects.
Is stupid
Sorry,
German
that
still
sounds
on there?
very like.
Or is
Sorry,
that the last one?
I'll be quiet. I'll just shut up.
L'Hopital's, you also need to be able to apply L'Hopital's. The limit of the top, you need to do the proper stuff for it.
Did we like use some and stuff?
And U substitution is chapter 6.
So that's next.
Yeah.
Slay. I heard it makes stuff easier. I think that sounds like a W.
Okay, guys, L'Hopital's. This is what you need to do for L'Hopital's. You need to pull them out separately. I checked. Delta Math definitely hits this. If you ever look at their solutions, they're like, you need to pull these out separately. We get a 0 over 0. What are the other conditions where L'Hopital's applies? Infinity over negative infinity, or any infinities over infinities. All right, so this, I tested the top, I tested the bottom, I got 0 over 0, so I can do the L'Hopital's, which means do what? Derivative of the top, derivative of sine is cosine, derivative of the bottom is 1, cosine is 0, you guys already told me, you know, that is 1, so this is the most simple application of L'Hopital's. Yes?
Should it be like 0 over infinity?
It cannot be 0 over infinity. What is 0 divided by infinity? 0. I have no cookies to share with everybody. But, so everyone gets nothing but with love. Yes? Yeah, this is the one that I said, just memorize, which you weren't in my class, but we talked about it. And there's this little icon for it over here. These images are all calculus and math things. This is Princess Kate and Prince William. When they become king and queen, they're going to have new crowns and they're going to be stepping on them. I don't know why. That's raise the power, divide by the new power. This one, as you're approaching the limit, you reach your limit and the X is getting frisky with the 0. She's approaching the 0. It's sign language X, sine X over the X's. We're number 1. This child is now like working at an NGO down the street. Yep. This is sine X written in a square plus cosine written as a square. Sine squared plus cosine squared equals 1.
Oh, isn't it just like any company?
They're so smart.
Isn't
Well,
it?
usually